Inshallah, in this video, I will proceed with 2.4, the multiplication rules and conditional probability. Okay, previously we have learned about the addition rules for probability, where you have to deal with the union. In this topic, we are dealing with the and intersection. Okay, so for the multiplication rule, you may look at the definition here. Okay, hopefully you can see the slide. Okay, used to find the probability of two or more events that occur in sequence. For example, when we toss a coin, okay, toss a coin will be the first event, and second event will be when we roll a die. Okay, so we have a sequence of two events here. So we are dealing with the multiplication rule. And for the independence event, when you have the occurrence of A, probability, the occurrence of A, it does not affect the probability for event B to occur. Okay, that one is the independent event. So let us look at this example one. This way. Things. Okay. Example one. When you roll a die, then getting a number 6, then roll a second die, getting a number 3. This is a simple example on independent events. Okay, let's say when you roll a die, you'll have either number 1 up to number 6, right? Let's say here we have number 6, already 6 here. So we have this is 5. Maybe this is getting number 4, this is getting number 3, this is getting number 2, okay, sorry, and this is getting number 1. So when you roll a die, so this will become the outputs 1, 2, 3, 4, 5, and 6. So what is the probability of getting all these numbers? Okay. Let's say you want to get number 1, the probability is 1 over 6, and the probability of getting number 5 also 1 over 6, getting number 2 also 1 over 6, and in our case here we want to get a number 6. And number 6 here, the probability will be 1 over 6. Okay, so we have 1 over 6 on this branch, and then roll a second die and getting a number 3. To get a number 3, when you roll a second die, let's say we proceed with this one. This is number 3. We can also get number 4. We can also get number 5. We can also get number 6 here. And before that, we can get number 1. And also, we can also get number 2. But here we focus on getting number 3. And here just now we are getting number 6. So the probability of getting number 3 here is 1 over 6. Okay, so if you can look carefully, the probability of getting number 6, it does not affect the probability of getting number 3. The probabilities remain the same. Okay, so this is the example of independent events. Okay, when event A and event B are independent, if the probability of event A occurring does not affect the probability of event B occurring. Okay, so this is from example 1. Okay, part 1, rolling a die and then rolling the second die. Okay, next is example 1, part 2. There are 7 blue balls and 3 red balls. Select a blue ball, then replace, and then select a red ball. Here when you have an urn, or you have okay, any basket. Okay, so in this basket we have 7 blue balls and also 3 red balls. Total is 10 balls. Okay, total is 10 balls. So for the first selection of the ball, the probability of getting a blue ball, okay, let's say this one, this is the probability of getting blue ball, it is 7 over 10 because the total number of blue ball is 7, right? So the probability of getting a ball which is blue, it is 7 over 10. The probability of getting a red ball in the first selection here, it is 3 over 10. So make sure you write the probability on this branch. Okay, and for the first selection, either you will get the blue ball or you will get a red ball. Okay, in this example, select a blue ball, then we need to replace it back. After you select this blue ball, then you need to replace it back. Okay, so for the second selection, you need to take a red ball from this basket. So what will happen to the total number of balls in that basket? It will remain 10 balls, okay? So that's why for getting a red ball in the second selection, it will remain 3 over 10. Same as selecting the red ball in the first place, okay, which is 3 over 10. So when you have the same probability here, it means that the occurrence of event in the first event, it does not occur. The probability in the second event, maksudnya dia sama kan? Ini kan? So this is independent event. So this is example of independent event sebab dia replace it back, right? So here, this is the notation for joint probabilities for getting blue and red. Okay, so this is blue and red. So to get the value of this joint probability, or we have intersection between blue and red, we can look at this formula. Okay, so you can simply multiply 7 over 10 times 3 over 10. So you'll get here 21 over 100, or you may leave 0.21. This is the multiplication rule. Nampak kat sini dia multiply kan? Inilah, this is the multiplication rule. Multiplication rule. So you may read this note, the probability of getting number 3, but number 3 is still the same. The first event of getting number 6 does not affect the probability of the second event, which is getting number 3. Probability of getting number 3 is remain 3 over 10. Okay, the probability of getting a red ball is still the same. The first event of getting blue ball does not affect the probability of the second ball, which is getting a red ball. Sama je definition. So from here, for independent event, we can use this formula. Okay, use this formula, which is if you want to get probability of A and B, you can simply take probability of A alone multiply with probability of B alone, because they are the same value as the first event. Dia tak ada berubah apa-apa. So that's why kita boleh gunalah this formula. Okay. Okay, now we look at this example 2. We have a coin is tossed twice. It means that for the first toss, what is the outcomes? Either you are getting head or tail. Right, this is for the first toss. Shilling yang sama, lambungan yang pertama. So the probability of getting head is 1 over 2. Same thing here, the probability of getting tail also 1 over 2. Then we move to the second event. If you toss the same coin, you are getting either head tail, and here also either head tail. So what is the probability of getting head in the second event? It remains, right? It remains 1 over 2, 1 over 2, 1 over 2. So this is the example of independent events. Okay, the probability does not change. Okay, the probability of getting tail, it does not change if you perform in the second event. Okay, in the second event. So these are independent events. So the probability of getting H and H, this one is actually probability of H, or you may write in terms of intersection. So we may take probability of H multiply with probability of H. That will give you 1 over 2 times 1 over 2 equals to 1 over 4. Okay, clear about independent events? Okay, Alhamdulillah. Okay, next we will look at